Hi, and welcome to this new playlist on database performance. Is this about performance management? Or is this about performance tuning? Or is this about performance engineering? Well, it depends. What is performance? It's about meeting expectations. It's about meeting service level agreements. It's about completing tasks on an accepted amount of time. Is performance management an art or a science? Is it easy or difficult? Well, it depends. Art or science. Science is about logic, it's about proof, it's about theorems. That's typically left-brained. Art, in general parlance, is about creativity, which is right-brained. But if you observe carefully, every scientist or artist in any field is actually whole-brained. What do we mean by that? It's just not about theory, it's not about proof, but also about creativity. If you look at artists, it's just not about creativity, they also have to know the science. If I take the case of a painter, he needs to know when I mix one color with another, in what proportion should I do that so that I get the color that I want. So there is science involved there, as well as when it comes to the art aspect of creativity, the artist needs that also. So take any field of art, be it creating a painting, a sculpture, or a musician, all of them are approaching it in a whole brain manner. Same is the case of a scientist. There is theorem, there is proof, but then there is also creativity involved in getting things done. Performance is also a whole-brained approach. You need to know what, how, where things work. At the same time, you need to bring up that spark of creativity in you to do the change that is required to get the performance benefit. Is it easy or difficult? Well, what is easy and what is difficult? When you don't know something, then doing that is difficult. But the moment you know how to do it, it's easy. Let's take a very simple example. If you know to ride a bicycle today, then it is easy. But rewind back to a day when you did not know how to ride a bicycle. At that time, riding a bicycle was a difficult task. Now, what is it about riding a bicycle? You know that bicycle has two wheels, it's got a pedal through which you give it momentum, you have a bar in which you hold, and you balance. Now, this balance is a part that can't be necessarily taught, because the science behind it is simple. Whenever you go left, you need to bring it back to right. If you fall towards the right, you need to get back to the center, that is, move yourself to the left. But to get that done is an art or a skill that you need to get. So when you were learning to ride a bicycle, probably you had somebody holding your seat behind and telling you, hey, you need to balance, you need to balance. And you would have been thinking in your mind, hey, if you can get me a few kilograms of it, give me, I will use it. Because you did not know how to do that. But then there was that one day, that one moment in which you got that skill of balance. And you knew, hey, I know when I'm going in which direction, and you could balance yourself. And thereafter, bicycling became easy. You could even let go of both your hands and cycle through. If you remember the days when you learned how to ride the bicycle, did you fall? Did you get hurt? Did you see blood? But did that stop you from continuing your efforts in learning? That's the attitude you need to maintain to learn anything new. Performance tuning might be something new you're attempting. In fact, whatever you might try to learn afresh is going to be difficult. But continue your perseverance and you will surely get it. I don't know which number is correct. I've heard about 1,000, 2,000, 5,000 or 10,000. Thomas Alva Edison was a person who had a lot of perseverance. If I take the quote as 1,000 attempts, so he was asked, did you have 1,000 failures and then found how a bulb will glow? Edison said, no. I had 1,000 successful attempts through which I knew how a bulb will not glow, and then I had one successful attempt in which I knew how a bulb can glow. The crux is, success and failure are just results, but you always have something to learn. Managing performance, engineering performance, tuning performance falls under that category. Keep that attitude with you when you approach any learning, and specifically managing performance, build on top of every learning that you have. All the best. Many a times I get a question from my colleagues, from my participants, from my customers. What is the best I can do to make my database run in the best possible manner? Well, it depends. That's because every situation is unique. Every situation has a particular problem which has to be overcome. And there is no single solution that can fix all problems. Correct? When you think about a single solution could fix all problems, then Oracle would have bundled it as part of the database. Why give you a choice? The simple reason that has been put up is, depending on your situation, depending on the scenario, you implement the right choice. So managing performance, engineering performance, tuning performance comes to a situation where, depending on the situation, you give the option that would work best. Here is a very important tip. If at all you are in an interview and somebody is going to ask you a question on performance and ask you, what is the best way to do this? And the best way you can answer that question would be to say, it depends, and then give the answer. The moment you say it depends, the interviewer is going to realize, this guy knows something about performance, because there is no fixed value. So depending on the situation is when you're going to do things. So performance management is also a scenario-based approach. Given the situation, you take the best decision for that scenario. We come to a point to talk a little bit about what's there behind me. Behind me, you have a picture of a long, winding road down a hill. Managing performance is something very similar to that. When you need to drive down such a road or ride down such a road, you don't have a straight view of what's ahead of you. You don't know what's the traffic when you just take a turn. You don't know what's the condition of the road. You don't know what's up ahead. You make use of your driving skills to the best possible manner so that you have a comfortable drive, a safe drive, and also reach on a timely basis. You might have to take a left turn or a right turn. You might want to avoid, if at all there is a pothole, or there might be snow. So you need to manage it depending on the situation. Performance tuning, performance management is something very similar. What you see behind me now is a road that is visible straight ahead for quite a distance. Now, driving on this road is far easier than on this road. Obviously, basic administration tasks are like driving down that straight road, whereas performance tuning, optimizing, engineering for performance are all tasks which need much more attention, much more skills, and that's how you approach performance. In this playlist, with the series of videos that are going to come up, I'm going to help you understand very, very important concepts of how do we approach performance and how can you become a good performance engineer, a good performance tuner, a good performance manager. I also would like to bring up the fact all through this playlist, in my background, the image or the photo or the background would be something to do with travel, transport, or any such activity that we generally do on a daily basis, which is something everybody can appreciate. And using the context of that example, I will help you understand the concepts behind tuning databases. You would have to travel to work, you might travel on a holiday, or you travel on a business trip, or you read about a new rocket being launched, or a new mission to Mars. All of these are different kinds of transportation scenarios or travel scenarios, which is generic in nature, but still will help us understand the concept of performance in a very, very easy manner so that you understand concepts and apply them in your daily job in tuning. Look forward to the videos, and I'm sure you will gain a lot of insight. And if not becoming a great tuner, I at least look forward to each one of you being able to interpret an AWR report. What is performance engineering? Let's first understand what is engineering. Engineering is about designing and building solutions. Specifically coming from the software line, we're looking at designing software, building it, and putting it to production. Generally, what we do when a software requirement is in place is we ask for requirements, we focus on the functionality, we design to make that functionality happen, we then write the code to make that happen, and we put it to production. And then we'll end up finding issues. Why is my software not scaling up? That's because you forgot a very, very important aspect of engineering, which is performance engineering. Unless you know what are the non-functional requirements, how are you going to build your software to do that? Let's take a typical transportation requirement and parallel it with performance engineering in software. There is a requirement to transport from point A to point B. How would you do the transport? We have various choices. I could use a bicycle and move. I could use a motorbike. I could use a truck. I could use a bus. I could use a car. I could use an airplane. Or I could use a space shuttle. The fundamental thing that we need to keep in mind is what is the source and what is the destination for which the transportation requirement is, and then what am I going to move? What is the payload? If the requirement is that I need to move from this room into another room or from this location to another location which is 100 meters away, maybe I don't need any solution, I can just walk. But if it is about going a few kilometers, then maybe I might consider any of these modes. Then comes the question about what is my cost, what is my timelines, and then you identify which is the right solution. If I have to transport from location A to location B, wherein location A and location B are two sides of the earth, then a bicycle may be a viable option, but it's going to take a long time to go around. You might want to then consider, should I use a ship or should I use an airplane? If I'm going to consider an airplane or ship, cost is one and time is another. Of course, it's going to be cheaper if you use a ship and not an airplane. But time, if you want to ship it in time, then you use an airplane. If it's about a person to be moved from one location to another, you're going to use an airplane, which is a passenger aircraft. Whereas if it is some goods that you want to transport, then it could be sending it through cargo. All these transportation modes that I talked about use metal, use rubber, use fuel. So the building blocks are the same. But then they are designed and built, which comes as part of engineering, and keeping in mind what is going to be the payload, and keeping in mind the cost, and keeping in mind the timeline in which the task has to happen, we get all these different transports. It is not that the metal itself is a problem, or rubber itself is a problem, or fuel by itself is a problem. How you use it is where the challenge lies. When it comes to software, it is the same. You might use Oracle database, you might use any programming environment. For various reasons, you choose your technology. But how do you design, how do you engineer, and how do you build, and how you deploy will result in the performance that you get. In general, we get functional requirements. It is important we also engineer a solution keeping in mind the non-functional requirements. Now, what could be non-functional requirement? To give a few examples, if I am talking about building an application, may I know how many users will be accessing it concurrently? Then, how much of data would be present in that database once it is built into production? How will users access it? When I look at an overall performance perspective, geolocations, meaning where is my application going to be hosted and where is my user going to come from, will result in the network aspect to be considered. So all these have to be considered, and then what is going to be my workload? Because your software could have 100 or 1,000 different features in terms of transactions that you can do. Which ones will be accessed at which point of time? So there could be 1,000 different use cases that can be used. All 1,000 may not be put to use simultaneously. There might be a case where people log in at the beginning of the day. They perform transactions of different types during the day, and they log out at the end of the day. If you're talking about an 8-hour work. But if you're looking at a global deployment, then there's a 24/7 uptime, and you need to work on modeling your workload to then identify how is my application going to be used, how is my data going to reside, and now you know your payload, you know how it is going to be used, and now you have the problem at hand, not just about the functionality, but also about performance, and then you build after performing a design which keeps in mind performance in every phase of the software development lifecycle. You start with requirements where you get non-functional requirements, which talks about performance and security. Then you go into design, where you look at what are the various options in which I can do this given the background of the non-functional requirement. Then you build it, you code it, you develop it to meet that, and then you test it. In all these phases, you're going to keep your non-functional requirement also in mind, meaning you will all through keep track of the number of users, the number of concurrent transactions, the number of rows in these tables. And once you have that in mind, then you're going to look at what are the possible ways in which I can engineer the solution to give the best performance. And then when you go to production, you get what you thought it will work like. Otherwise, it could land up that you wanted to ship from point A to point B. That is the requirement you got, and you brought about a spaceship wherein the requirement was just to move something from point A to point B, which was 100 kilometers away. A spaceship will not necessarily deliver it faster than maybe a truck. So what's performance tuning? You've already designed, built, and deployed a solution, but it is not meeting your performance needs. Then you are seeing that your SLAs are not being met by the application. So now you need to go and figure out what is the problem. This results in tuning the problem. But what is a problem? Whenever we talk about a problem, we need to know the root cause behind why that is happening. Whenever we talk about root cause, the term that we associate is diagnosis. When we talk about diagnosis, I am always reminded about a physician. The most important task of a physician is to identify the root cause based on the symptoms that the patient is undergoing. A symptom could be temperature, it could be pain, it could be whatever the patient is undergoing. But then the root cause, the reason why the symptoms are appearing could be many. We are lucky being in the software field because when we see that there's a performance issue, we would like to reproduce it. And then we can try out options and then we find a fix and then we put it back on production. Imagine the case of a physician. He does not have a test case to go and test it out. He has to do it on the patient. So there's a lot of science involved to find out how to go about it. The process of diagnosis is nothing but identifying a root cause. And to do this, we need data. We need data to identify how from symptoms we can arrive at root cause. And we will go into this in detail as we proceed in this playlist. Of course, trace files, alert log files, AWR reports, ASH reports, and many other means of digging into data is available, just like how a doctor might check your pulse, might check your temperature, might ask for some tests to be done to identify what's happening inside. Now, once you identify the root cause, then identifying the fix is actually much easier. It's like telling, how is a pharmacist different from a physician? A physician's job is to identify the root cause, and then he gives you a prescription which you can take to the pharmacist to get the medication. You might wonder, I could have gone to the pharmacist and get the medication upfront. But only when you know what is the root cause can you get the right medication. Similarly, when it comes to database tuning and troubleshooting, troubleshooting enables you to identify the root cause, then you look at solutions of tuning that. So when we talk about tuning, what do we talk about? There could be SQLs that are bad, SQLs that are consuming a lot of resources. It could be just that the database was not configured sufficiently. It could be that there are too many different types of requests coming. Can I manage that better? Can I add indexes? Can I use resource manager? Various tools available through which we can identify how to go about tuning. Can I change the way an object is stored? For example, instead of a heap table, can I use an index organized table? Can I use a clustered table? Should I use materialized views? Should I use partitioning? Now there are n number of options, but then depending on the problem, the solution would be specific to that problem. The symptom could be SQL taking time, but the solution may not apply in every specific scenario. So tuning is about applying the right solution for a given case. It could also be that there are weights. What are weights? I will discuss in another video. Sometimes it is just about weights that you need to solve, not about other options. Performance management, what is that? Maybe your database is already very well tuned, but just that the workload is very heavy. And you see that there are some low priority transactions that are finishing off very fast, And there are high priority transactions which are taking more time. You just want to give these low priority transactions lesser resources and let them wait, and let the high priority transactions get more resources so that they finish off faster. So when it comes to performance management, we are not going into doing tuning, but we are managing performance so that we are meeting our SLAs. We are ensuring the critical operations are finishing off. The less critical operations may take more time. This brings us to a point to talk about what's in your bowl. You must have had applications of different natures, different types, different uses. Did they all perform well? Did they all perform bad? Or were there some which worked well and some did not work well? Well, the question is, those that performed well or those that performed bad, was it by luck? Was it by chance? Never. If you keep performance engineering in mind and had the non-functional requirements wherein you knew about how your application will be used, then you will build it to meet those requirements, and obviously there are not going to be much surprises. In general, you might find that on putting it on production, I have issues, which means you did not know how your product is going to be used, or you did not know how your solution is going to be used. So there's a lot of efforts involved even before you start designing, which is to understand how, when, where, why a product would be used, so that then you can engineer it, you can design it, and then develop, test, and deploy. What's in your bowl? What do I mean by that? Let's take a simple example. On the right hand side, I have a large bowl. On the left hand side, I have a small bowl. This is an analogy about you having a resource which is in more quantity and a resource which is in less quantity. What is a resource? At a high level, we can say memory is a resource, CPU is a resource, network is a resource, disk and I/O is a resource. To understand how resource utilization happens, let's take these two scenarios. Just because I have a lot of resources, does it mean I can do more with it in comparison to a situation where I have a smaller resource? Well, the question is, what do I mean by do more? Let's take this situation. I have a tennis ball and I have ping pong balls. Let us say I fill my large resource with tennis balls. Does it mean it is able to hold more tennis balls? Yes, when I look at it from the small resource, I can hold only 1 or 2 tennis balls at the maximum, whereas I can hold 7 or 8 tennis balls on the right hand side. But the question is, do I want to hold tennis balls? What if I wanted to hold only ping pong balls? Then, in spite of having a large resource, I am not doing what I wanted to do. It is able to carry much more, but that's not what I wanted to do. If my small resource can hold 4 ping pong balls and my large resource is also holding only 4 ping pong balls, then both are doing what I want. Just because I have a larger resource, it does not mean I can do more. Reason being, tennis balls are things that I don't want to do, but I'm still keeping it there. Same way, in a database, CPU, memory, network, I/O are all resources which have to be optimally used. If you can use your resources optimally, your system will perform well, meet SLAs in spite of having lesser resources. If I were to consider CPU as a resource, if I do a lot of tasks which have no value addition in my application, for example, when you do excessive parsing, why do we do excessive parsing in a database if you are using literal values? If you used bind variables or prepared statements, then you will not do unwanted task of parsing which means you save CPU time. Similarly, when you land up using bind variables, you save memory, because if you use literal values, every SQL, in spite of the fact that two SQLs look the same, for example, select star from employees where employee ID is equal to 100 and select star from employees where employee ID equal to 200, from the look of it, both look the same. But as far as an Oracle database is concerned, they are two different SQLs, because the hash value of both the SQLs are different for the simple reason the literal value 100 and 200 will result in two different hash values created. On the other hand, if I had used a prepared statement or a bind variable by putting where employee ID equal to B1, then when I pass in a bind variable of 100 or 200, the SQL still remains the same. Now imagine you have 100 such queries running with different literal values. This is going to result in a separate SQL area created for each SQL in the shared pool if you use literal values. On the other hand, if you used bind variables, it would result in just one SQL area. An example where I have ensured I can use less resources and still deliver more. Thirdly, if I'm doing a full table scan, I'm reading a lot of blocks. If I use an index-based lookup, and by doing so, if I read lesser blocks, then I am doing less I/O. Number two, I am doing less network transfer from the storage into the database server. And on the database server, I am keeping less blocks in the memory. Very trivial, but go and look into your database. Go and look into how your application is accessing. What is critical is not how big a resource you have, but what are you doing with your resource. Try to cut down all unwanted tasks, unwanted things, or write your code in an optimal manner so that you can do more with your given resource. You don't need to necessarily increase your resource. It is very important what is in your bowl. What are those activities that you should avoid within a database? Number one, generally the most significant problem causing thing in an application, from my experience and from experience of many other professionals, is bad connection management. You need to remember, making a connection to the database is one of the most resource intensive operations that the database has to do. Because when you request a connection, the connection request goes to the listener, and then the listener has to spawn a server process in the instance, which means it has to request the operating system to create a memory structure and create a process. And then CPU cycles also have to be shared for that resource or process. You perform your operation and then you disconnect. And when disconnecting again, that is another costly operation. In fact, performing a disconnect in a database is more resource intensive than making a connection, because the database server has to clean up the process and hand over the resources back to the OS. And the OS would have to then make it available to other requests. Connection management is something very important. A best practice for a well-tuned system is that a database does not see any new connection requests coming in or log offs happening during its peak load, or for that matter during any time. When an application starts up, let it make all the connections, and whenever you shut down the application, let it disconnect. Otherwise, as the application is running, you should ensure that no connection requests for making connections or logging off should happen. How do you find this? It's available in the AWR. I will come to that topic a little later. Second, bad SQL. What is bad SQL? There are two ways of looking at it. Number one, the SQL is written bad. What do I mean by SQL is written bad? A simple example could be, you are joining three tables in a query, and if you are joining three tables, there should be 3 minus 1 join conditions. So you should have where table 1 equal to table 2 and table 2 equal to table 3. There should be a reference between all the three tables. Let's say you missed one of those join conditions and you have only one join condition. It's going to result in a Cartesian join. That's bad SQL. But Is it that all SQLs are going to be bad? No. Generally, SQLs are written well. There could be exceptional cases where SQLs are not written well. Second, putting function calls. Try your best to avoid function calls in SQL. Unless it is really required, avoid them. Why? When you make a function call inside a SQL, it has to do additional work other than just fetching the data for the table, because it has to process the function call. 3. Performing full table scans. Well, that's a very arbitrary statement. Again, full table scan per se is not bad, but if you're doing a full table scan on a large table, that's a lot of I/O memory utilization that's going to happen, and CPU processing also that is going to happen. Next, putting in hints. If you put a hint, you are forcing the optimizer to execute the query in a particular way, and the optimizer loses out on better opportunities that it can find. I am not saying putting hints per se is bad. Rather, putting hints should be the last resort. When should you put a hint? When you know that the optimizer is behaving wrongly and you know you have a better option to execute the query, then put a hint. Using function calls in the where clause. Instead, try to have the data correctly kept in the table so that you don't need to use a function call, or use function-based indexes. These are some scenarios which are outrightly visible. But what if your table design was itself flawed, that your query has to have a very complex structure to query the data out? So if your data model itself is flawed, then obviously your query will have a roundabout way of doing things which can make your query run inefficiently. So you might want to look at whether your data model is appropriate, whether you use the right data types, and that can also result in a SQL being bad, wherein the SQL per se is not bad, but the underlying data model is having a mistake. When we execute a SQL, the SQL executes and you get a response. The total time taken to execute a SQL is called as SQL elapsed time. But what happens in this elapsed time? There are two primary components as far as elapsed time is concerned. Number one is the amount of time the SQL spent inside the database using CPU, and the amount of time the SQL spent in waiting for something. Sum of CPU time and wait time is your execution time. So why would my SQL wait? Or wait events, why do they happen? There could be various reasons. But first of all, let's understand what is a wait. If you are traveling from your house to your office, there might be a certain amount of travel time involved. But that travel time is the total time taken for you from the time you leave your house till the time you reach your office. But are you traveling all through? May not be. Sometimes you sit in your car or you get into the vehicle of your transport and you just keep driving all the way and stop right at your office. But that might not be an ideal situation that you face every day. You might have to wait, and you might have to wait for various reasons. To begin with, you might have to wait because of traffic lights, or you wait because of traffic that has piled up on the road, or you wait because of some other reason which is not allowing you to move forward on your road. There are various reasons why you wait when you travel. Similarly, when you execute a SQL, execution of SQL means it has to process the data and give it. If the data is available in the memory and the query can get processed, then there is nothing it would have to wait. But there could be situations where, for various reasons, it could be I/O related waits, it could be waits in the memory itself, it could be waits because of locks, various reasons. We will get into wait events per se later. What I wanted to tell you in this is, SQL execution is made up of two components. One is the amount of time it spent processing your query using the CPU, and the other is where it had to wait because of some reason. These waits can cause more time to be spent in your SQL execution, which means you need to troubleshoot that. But if your SQL is spending a lot of time in CPU, then you may want to figure out, why is my SQL using a lot of CPU? There could be reasons for that also. But finally, tuning falls under these two categories when it comes to SQL tuning. What is DB time or database time? This is something you must have encountered if you at all you had an opportunity to look at an AWR report. I already told you what is SQL elapsed time. That is the time taken by a single query to execute and fetch results back to the user. Now let's say a database is running for 1 hour. When a database is running for 1 hour, the total elapsed time for the database is 1 hour. Now let's see some scenarios. Scenario 1. There was nobody who was doing anything inside the database. Still, the database was running for 1 hour. But what was the work done by the database? 0. Nothing. Scenario 2. During the same 1 hour, let's assume there was just one user who was logged into the database, but he ran just one SQL which took just 1 second. Which means during the entire 1 hour period, the amount of work done by the database was just 1 second. The remaining time, that particular user was idle. He was active just for 1 second. Scenario 3. Let's say there were 100 users logged into this database and they executed 100 SQLs each. And let's assume each SQL took 1 second to execute. Then we have a situation where there were 100 users who executed 100 queries each, which each took 1 second to execute. The sum of total work done is 100 into 100 into 1, which is 10,000 seconds. So during this 1 hour period, if this is the work that was done, then the total work done by the database in this 1 hour period is 10,000 seconds. Given these three scenarios, scenario 1, where no work was done, scenario 2, where just 1 second of work was done, and scenario 3, where 10,000 seconds of work was done, the total elapsed time as far as the database running time is concerned was just 60 minutes or 1 hour. Whereas 0, 1 or 10,000 is DB time. Thereby, DB time is nothing but the sum total of all SQL elapsed time in a database. Or it is the sum of all the work that was done within the database. It does not include the inactive time for all sessions. But please note, every SQL would have used some amount of CPU and might have waited for some time. If I aggregate all the SQL elapsed time, then DB time is arrived, which is again made up of sum of all CPU time and sum of total wait time for all SQL executions. This is what is DB time. So DB time per se need not be lesser than elapsed time of a database or need not be more. It only tells how busy was the database, how much work did the database do. And at the same time, if DB time can be split into CPU and wait, if your database is spending a lot of time on wait, then you need to do something about it. But if your database spent a lot of time in CPU as part of the DB time, then your database is running well. This is how you interpret DB time. When you create a table space, the table space could have extent management as dictionary or locally managed. Earlier, till 9i, there was only dictionary managed table spaces. From 9i, the option of having locally managed table spaces was also brought about, and today it is the default for any table space that you create. So what is the difference between these two? What do we mean by extent management? In a table space, there are many extents. Which segment has used an extent and which extent is currently free is what is the meaning of extent management. So if you create a new table on a table space, the table space will have to allocate to that segment any extent that is currently free. In a dictionary managed table space, the assignment of extents and identifying free extents was managed within the data dictionary, which means whenever you create a table or you truncate a table or you drop a table, it resulted in internal DML operations happening within the dictionary, which resulted in redo entries getting generated, and there was a lot of contention for the dictionary because of such DDL statements. Thereby, Oracle introduced the concept of locally managed table spaces. Now, when extent management is local, then the table space itself maintains information about its extents. The header has a bitmap. The table space data files have a header in which there is a bitmap which has a pointer to various extents, and it also keeps track of which extents are used, which extents are unused, so that this does not make any impact inside the dictionary and redo generation doesn't happen, contention for dictionary is reduced, and thereby it is much more efficient and more performing when compared to dictionary managed table spaces. When it comes to locally managed table spaces, segment space management can be of two types. It could be manual or automatic. What is the difference between manual and automatic segment space management? Segment space management, as the name suggests, is managing the space within a segment. What is this for? In a segment, generally, you have used blocks and unused blocks. Used blocks are blocks in which an insert has occurred, whereas unused blocks are those which have never been used in this segment for doing any DML operation. If that be the case, how does it identify from when on are there unused blocks? That's where we have something called as a high water mark. All blocks beyond a high water mark in a segment are all unused. The significant factor behind this is when a full table scan occurs, the blocks are read only till the high water mark for that segment. So that's what is a high water mark, which demarcates between used blocks and unused blocks in a segment. Within a block, there is space available. That is where rows are kept. Now, how is this space managed? There are two important parameters that come up when you do manual segment space management, and they are PCT free and PCT used. In the case of automatic segment space management, PCT used is not having any relevance, but PCT free does have. Let us see how these two work in tandem. Every block is having free space and used space and a header space. A manual segment space managed segment has something called as a free list. Whenever somebody wants to insert a row into this table, they will have to identify into which the insert can happen. Such blocks where an insert can happen are maintained in the free list. So if 10 users want to do simultaneously insert on a single table, all of them would have to refer to the free list to find, give me a block in which I can make an insert. So free list basically contains list of blocks in which inserts are allowed. Now, how does a block come into the free list or go out of the free list? That is where the two parameters, PCT free and PCT used, come into play. PCT free states, how much of free space should I reserve for future updates for the rows that are present inside a block? For example, if I know my application behavior is going to be as follows. Let's say I have 10 columns, and for simplicity purposes, let us assume all 10 columns are equal in size, meaning similar data type and similar size. And I know when my application makes an insert, it inserts values only into the first 5 columns and the other 5 columns are null. And I know over the next few days or few months, the other 5 columns will also be updated, then I know my table is not going to get fully populated for every row at the time of insert, and instead I need to reserve some free space for the updates that are going to happen for the remaining 5 columns. If that be the case, in a block, let's say I have a 4 kilobyte block, and assuming we will forget about the header overhead, when I insert one row, only 50% of the row's total capacity is inserted into, and I will later update the remaining 50%. Let's assume each row occupies 1 kilobyte in all, which means 4 rows can be kept in a 4 kilobyte block, but on insert, only half a kilobyte is inserted. Now, if I leave it as it is, this block can get fitted with 8 rows. And when I do an update to a row from 0.5 to 1 kilobyte, the block may not have space to accommodate the update. Thereby, we reserve space. When I know on an insert a row will have only 50% of the data populated, and in future updates the remaining 50% will come, a good practice would be to set PCT free to 50, which means when I keep inserting rows into the block, the moment 50% free space has reached, then this block will be removed from the free list. Thereby, no more new inserts can happen into this block. Thus, I have achieved my objective of ensuring 50% free space is reserved for future updates. And now when I keep updating these rows, the block can accommodate the updates. Now that's okay as far as I'm doing updates. But now that this block is removed out of the free list, no more inserts can occur. But there is a possibility I delete some rows from this block and there could be free space available. So should I not populate rows into it? That is where PCT used comes into play. PCT used determines when can a block which has been removed from the free list be brought back into the free list. For example, if I have set PCT used to 30, then when the used space in the block comes to below 30%, then it will add the block back into the free list. Thereby, new inserts can now happen in this block. This is how free list management is taken care by using PCT free and PCT used. If you are using automatic segment space management, then how much space is filled in a block is managed automatically with a bitmap in the segment header. The only parameter that will be considered here is PCT free, meaning in a block, certain amount of space will be reserved for future updates, but it is not going to take care of PCT used. How does it manage this? It basically has different bitmaps for blocks which have different amount of used space, so that depending on the operation that is happening, which is inserts, it decides which block it can do the insert into. Row migration and row chaining. There are two important things which come about as to how a row is structured. You must have already seen my video about how a block is structured, within a block how rows are structured, and we also looked at how PCT free and PCT used work. If you land up not configuring PCT free appropriately, then a block could have more rows inserted into the block than it should have. And you go about updating a row and there is insufficient space for that row in the block. Then what will it do? The row will migrate into another block. It still leaves a piece in the original block and that will point to the new block. What is the impact of this? When you need to read this row, you will come to this block, read this and realize it has moved into another block, and you will go and read that block. So instead of reading the row by just reading one block, you will end up doing multi-block IO to read just one row. How do we avoid this? By ensuring setting a proper PCT free We will ensure there is always sufficient space for rows to get updated, and thereby we will never land up having a situation to move a row from one block into another block because of lack of space. So this has to be planned upfront. Row migration results in more I/O when you read rows. You don't want this to happen. So row migration happens not because of an improperly sized block, that's not the reason, but because you did not reserve free space for the rows to get updated in future. On the other hand, if you knew that your rows will get inserted with all values of the columns and you don't see a reason why these columns or rows will get updated, then you can very well set PCT free to be 0. Thereby, the rows are tightly packed within a block and there is no free space left, and thereby you are using your space in the most optimal manner. Then comes row chaining. Row chaining happens at a time of an insert. Look at row migration. Row migration always happens during an update, but row chaining happens during an insert. Let's say you have a block sized 4K, but there is a row which is of size 8K which has to sit in. It can't sit within a 4K block. It has to move into 2 blocks to keep the data in 4K blocks. Row chaining happens because the block size of the database is smaller than one row size. This results in one row getting seated in 2 blocks with 2 pieces for the row, or more pieces if you have a larger row. How do we avoid this? Set the block size appropriately, or ensure your table design takes care that one row does not go larger than your block size. So even before you create a database, you need to think, design, and implement all these so that you have good performance when your database runs. In this video, we will see the impact of PCT free in terms of packing rows tightly. It is recommended that we pack as many rows as possible within a block so that when we want to fetch rows, the number of blocks to read is reduced. For example, if I have 1000 rows in a table, how many rows will sit in a block will depend on 2 factors. Number 1, how much of free space we want to reserve whenever a row is inserted to accommodate future updates, and 2, the size of the row itself. Let's take an example that a row occupies 1 kilobyte of space and the block size is 8 KB. If I have an 8 KB block size and I have set PCT free to be 50, wherein I'm going to reserve 50% of the space for future updates, then in a given block, I'll be able to insert only 4 rows, because when I insert 4 rows, 50% of the block is going to be occupied and the remaining 50% is left free for these rows to be updated. On the other hand, let's say we have PCT free to be 0. Then the same 8 KB block will now have 8 rows inserted. Now, which is right? Well, it depends whether your rows are going to be updated or your rows are not going to be updated. Again, 50 is just an example I've given. Depending on how much of free space you need for a row to be updated later, you accommodate free space accordingly. Now, given that I have 4 rows per block in a 50% PCT free sized segment and 8 rows per block in a 0% as PCT free, if I have 1000 rows on this table, then at 4 rows per block, I will need 250 blocks to store these 1000 rows. At 8 rows per block, it is sufficient to keep 125 blocks to keep all this data. Now, I/O, when I need to read this data, is going to differ. The same table with 50% packed rows, I will have to do 250 blocks as I/O, whereas with 0% PCT free, it is sufficient to read it with 125 blocks as IO. Not only am I affecting my IO, let's look at the buffer cache. The buffer cache is organized in the form of blocks. To read these blocks, I need 250 buffers, whereas to read these blocks, I need only 125 buffers. Now the difference is, I will be wasting my memory if I am not going to update these rows at all in the future by reserving 50% of space. Then I will be doing more IO. I will be keeping empty space of 50% in the memory, and I will complain that my SGA is small, my buffer cache is insufficient. Remember, this is an example of a tennis ball, whereas this is an example of a ping pong ball. So it's very important you decide how you size your PCT free and pack your rows. I also have a demo to showcase the same example. We shall create two tables and see what happens. The first table has PCT free 50. We will gather statistics for the same. And then we will create the second table where PCT free is 0, and we will gather statistics for the same. Both tables have the same data, but let's see what's the impact on the data that is stored and the number of blocks. As you can see here, the number of blocks used is much larger, PCT free is visible, and the average row length in both the tables are the same. Often, the most important question to ponder over before creating a database is to decide what should be the block size. I have told already many times in my other videos, there are 5 block sizes available: 2K, 4K, 8K, 16K, and 32K. Why are there so many options? Which block size should I set for my database? So there are 2 questions you need to ask upfront. Number 1, what am I going to do with this database? Am I going to predominantly do DMLs, which is manipulation, or am I going to query? DMLs means we are considering a transaction processing system. I will classify that as OLTP. Querying predominantly means it's a reporting system or a data warehouse system or an analytics system. We'll categorize that as a data warehouse or analytics system. So that's the first thing you need to ask. Sometimes you might have a mixed mode, but look at what will you be doing predominantly. The next question is, how much will I do? How many DMLs will I do at any given time? Or how much of data will I fetch at any given time? These 2 questions will help you to decide the optimal block size for your database. Let's take a simple example. We have a table which has got 1,000 rows. Now you can extrapolate this to 1,000,000 rows, to 100 million rows, whatever number. I'm taking 1,000 rows just for simplicity purposes. If I've got 1,000 rows in a table and each row is going to occupy 1 kilobyte of space, then let's do some mathematics. Number 1, considering the 5 different block sizes listed above, 2, 4, 8, 16, and 32, in each of these blocks, I can keep 2 rows, or 4 rows, or 8 rows, or 16 rows, or 32 rows, considering 1 kilobyte per row. For now, for simplicity's sake, I am just ignoring 0 as the header size. We'll come back to the header later. This enables us to calculate things easily from a learning perspective. Number 2, if I'm going to keep 1,000 rows in each of these sized blocks, how many blocks will I need to store this? Remember, Oracle block size determines the smallest unit of I/O Oracle is going to read from the data files, and that will be the buffer size in which your SGA buffer cache is going to be sized. So if you had kept your block size to be 2 kilobytes, then your buffer cache in the memory is organized into buffers of 2K. Every block from the data file is read into the buffer cache. If I have 2 kilobyte block size and I put 1000 rows in a table, then I will need 500 blocks to store that. If I had 4K blocks, 250, 8K blocks, 125, 16K blocks, 62, and 32K blocks, just around 32 blocks. That's what I will end up having in my table. Now let's get into some more details. Our assumption is we have already tightly packed the rows. That's why all the blocks, whichever be the size, they are all filled. Which means we might have had PCT free to any number, but we are assuming that the rows got tightly packed over a few updates over a period of time. But now, what am I going to do? Am I going to update these rows, or am I going to query from these rows? Whichever way you consider, let's take the scenario simple. If you're going to update, then you need transaction slots for every row that is updatable. So if I have 2 transaction slots per block, then in the case of 2K blocks, at 500 blocks required to keep all the rows, at 2 transaction slots per block, I have a total of 1000 transaction slots available for the table at any given time. And if you consider a single block, both the rows inside the 2K block are updatable concurrently by 2 different users. In the case of 4K blocks, I still have 2 transaction slots, and with 250 blocks, I have only 500 transaction slots available. Similarly, 16K blocks, I have only 125 transaction slots, and 32K, I have totally only 64 transaction slots, which means if I need heavy concurrency to allow multiple users to manipulate multiple rows simultaneously, then the 2K gives me maximum concurrency. Now you might argue, why not increase the transaction slot? Yes, you may. If you increase your init trans, then remember the header is going to grow. So then if you increase your transaction slots to be larger and you want, let's say, an 8K block with 8 rows in it to allow for 8 concurrent transactions, there is also a contention for the block in the memory in the form of a buffer when 8 people want to access it concurrently. So when you're going to have heavy concurrency, consider 2K blocks with the fact that you want to do as many concurrent DMLs as you want across different users. That allows that to happen. Sometimes you may even set PCT free to a larger value so that you don't want too many rows in a block. So choose the block size which will offer you the maximum concurrency expected from the application so that the database will not make you wait for it. Now the assumption is no 2 users are going to manipulate the same row at the same time. Now that's not what Oracle is going to allow. Oracle is only going to allow 2 different users to manipulate 2 different rows at any given time. If 2 users want to manipulate the same row, that is a contention for the same row with the help of a lock on the row. That's not what I'm talking about here. On the other hand, if you're doing querying, if you're doing reporting, then you want to get as much data as you want by fetching the block. So if I take the case of 32K block, by reading one block, I get 32 rows. And I can read the entire table by just reading 32 blocks. The number of IO operations I need to do is only 32 here, whereas if I had used 2K blocks to do querying, then I need to read 500 blocks. I have to read 500 blocks from the data files and bring it into the memory. Though the total amount of data is the same, the number of blocks is varying. So when you are doing querying, consider using larger block size. If you are doing DML, consider using smaller block size. Now when you are having a mixed mode, you choose the most appropriate block size by doing benchmarking on your application with a database with different block size and arrive at the most optimal block size for your application. In a database, when you experience that the database is running slow, or the database is consuming a lot of resources, or your queries are running slow, your end users are complaining that the database is not performing, then these are all examples of symptoms that people are facing. You as a DBA, as a tuner, would have to troubleshoot to identify what is the root cause. What is the problem that is causing all these symptoms? What is the root cause which is making the database behave slow? To do this, you need data, or you need diagnostic data. Just like how a physician might ask you to get some tests done, maybe a blood test or a urine test or an MRI scan, which enables him to identify what's happening in their body, the database to troubleshoot provides you a lot of diagnostic data. These could be in the form of $V views, it could be snapshot-based AWR reports, ASH reports, alert log files. There is a lot of data, but we need to understand which data to look at and how to interpret it. That's the idea behind the next few videos, and the first thing we will look at is $V views. $V views are dynamic performance views. Otherwise, they're also called as fixed views or fixed tables. These are part of the database at the time of database creation itself. There is a script catalog.sql which is run at the time of database creation, which creates all these tables. So this is part of the Oracle database itself. These views capture data automatically about what the database is doing, and they generally don't provide read consistency, and more importantly, they are in-memory data, meaning only when the instance comes up, it captures information. When you shut down, they are all gone. Another important aspect is the $V views generally have data aggregated since the time the instance was started. So if you went and looked at a $V view like $SQL or $SQL area, they will give you data since the time the instance started, what are all the SQLs that ran. You are not going to know about at a particular time which SQL ran. $V views don't enable you to go and troubleshoot to find out at a particular time what happened. That's not what is the purpose of $V view. $V view gives you aggregated data. From these $V views, there is something called as metric that is captured automatically by the database. Metric is about rate of change in performance statistics. And some metrics are captured every second, some every 5 seconds, some every 1 hour, etc. Different metrics, depending on how frequently they have to be gathered, are automatically gathered by the database. Beyond that, there is also something called as an AWR repository, or the automatic workload repository. What is this? You don't have time to go and keep looking at $V views on a regular basis. You're anyway busy with doing various other database administration tasks. The AWR is basically a repository of all this data taken in the form of snapshots. What is the objective of an AWR report? An AWR report is to give you a holistic picture about what happened in the instance or what happened in the database. Similar to in a city, if the traffic management department would like to see what is causing clogging in the traffic in the city, they're going to have a holistic view about what's happening in the city overall. They're not going to be bothered about what a particular car is doing. A particular car is similar to a SQL. SQL tuning needs different types of analysis. If you want to look at what a particular car is doing, then you need to sit inside that car and see how that person is driving. Whereas traffic management is not to look at an individual car, it's to look at an overall perspective and see what's happening in the city overall. Similarly, an AWR report's objective is to tell you what is happening in the database or in the instance during a period of time. How do we identify this during a period of time? The AWR basically captures snapshots. You can define how frequently you want these snapshots to be captured. By default, it is every 1 hour. What is captured in a snapshot? Snap is a picture. So the AWR snapshot basically creates a copy of all the $V views at any given time, and then another snapshot at the next point in time, another snapshot at the next point in time. So if I have configured AWR to gather 1 hour snapshots, then for example, I would have a 10 o'clock snapshot, 11 o'clock snapshot, 12 o'clock snapshot, and so on. At each snapshot, the data that is present is as of that time what was there in these V dollar views. When you create an AWR report, you are asked to choose what is the begin snap and the end snap. For example, I create an AWR report based on the snapshots taken at 10 o'clock and 11 o'clock. What is it going to do? Pretty simple. I have my metrics and statistics of performance as of 11 o'clock. I have the data as of 10 o'clock. Subtract the two, and the difference is what happened in that 1 hour duration. Now you know in the database what happened in that 1 hour. That is what an AWR report gives. If you want to look into a problem that happened, let's say at 10:30 in the morning, then you need to have the snapshot taken as close to 10:30 before and 10:30 after. If you took two snapshots, one which was taken 10 o'clock today and another that was taken at 4 o'clock today, now that's a 6-hour window in which if you want to troubleshoot something that happened in a 10-minute window between 10:30 to 10:40, it will be very difficult. So whenever you want to troubleshoot what happened in a database using an AWR report, try to keep two snapshots which are closest to the problem time so that you exactly get to know what happened in that period of time. Some customers also capture AWR snapshots in a 15-minute or 20-minute interval so that in case they have a problem at a 5-minute interval at any point in the day, they have a 20-minute snapshot interval with which they can capture what happened exactly. So it is generally not good to take a snapshot of 10 o'clock of one day and 10 o'clock next day, which is like a 24-hour period. You can get an overall idea about what the database was doing, but that may not be able to help you solve a problem of something that happened in a very small time period during the whole day. You need to take snapshots which are very close to that and take it out. Another important thing is these snapshots should be from the same instance to create an AWR report out of it. Let's say there is a 10 o'clock snapshot and 11 o'clock snapshot, but you restarted the instance at 10:30. Then this snapshot and this snapshot are not correlatable for the simple reason once the instance was restarted, the gathered statistics are new. They are from 10:30 onwards, whereas this was up to 10 o'clock. They are not comparable. Whenever you create an AWR report, it has to be for the same instance. Given an AWR report, there are various sections about it. It looks like a very complicated report, but my job here is to make it easy for you to interpret. What can you get from an AWR report? You can identify what did the database do in this period of time, or what did it face as a problem, or what were the top queries, what were the top resource consumed during this period of time, what did the database wait for during this particular period of time. These all are ways to troubleshoot and identify what the database went through during this interval. So Oracle database is a huge product. Tuning and troubleshooting is a skill that may not be done justice in the duration we have taken, but the idea behind what I'm putting up here is like a foundation and a bunch of skills through which you would find it easy to take it further, because each scenario is unique, and that's the foundation behind tuning. That's what makes it interesting and challenging, and that's a fun part of it. So we're going to look at all these topics. I hope all of you did go through the course contents as such. So let me go ahead. So basic idea behind Oracle database architecture is what I expect. An experience in already going through some cases of troubleshooting would be of help, not a mandatory thing, but it would surely help. So in this course, I'm going to look at thinking out of the box. It's not necessary you always get a tuning solution by looking into the problem. You'll have to look outside, and that's going to be a big focus, and I'm going to have quite a few examples in terms of how we look at it, and also some experiences about how I went about fixing some issues and things like that, which will give you a perspective of how you would have to approach. So if you had seen my video on YouTube on is performance tuning an art or a science? So I've already answered it there. It is a mix of both. So if you just take it as pure science and try to look at the rules, logic, etc., you may arrive at a solution. But if you look at it as an art, to look at, when I say art, it's about imagining and being creative about bringing about a solution, then it would surely help. And I will surely give you some examples on that front also. So here is our first example. So case study 1, we're going to spend some time on this from your experiences. So there is a complaint from users. When I say users, these are users who are using the application. The application is obviously connecting to the database, and the users are complaining that the application is responding very slow. And you as a DBA, or you went and asked the sysadmin who went about saying on the database server, CPU utilization is about 10%. So now the question to you is, what is going to be your initial reaction to this situation? I leave it open. You can tell me whatever you think is appropriate if you land up being in this situation. Okay, so you're basically looking at reproducibility to a certain extent. That's what I understand. How much data are you processing? What part of the application is being run? Current processes in the database. Fair enough. That's another perspective. And anything else? Okay, so this is a typical challenge we face. Locking, perfect, very valid point. So what else can be a case study that we can consider? So let me look at that next. So I'll come back to this. We'll come back to this. Whatever I've put up here as a case study, we will come back to this. So let me clear my whiteboard and go to the next slide. So case study number 2 says, as a system administrator, the complaint from the system administrator is, hey, your database server is running at 80% utilization of CPU. And you went and digged in and you found that, yes, there has been an increased load on the database. Now, how would you react to this? If this is the situation, the system administrator told you this, he's asking you, this is what is happening, do you know? And then you know that, yeah, you checked your application folks, and then he said, yes, we have now rolled out this application into a new geography, or we have rolled out a new app to connect to the same database, which maybe as a DBA you're aware. So how would you respond to this? So and then third case. So here is a very simple case. So I have a bowl and I have a challenge that I'm not able to keep whatever I want to keep in the bowl into it. I have a bunch of items. So what is the symptom observed? My bowl is running full. So what can I do? So here is the solution for case study 3, or the situation for case study 3, where I have a bunch of fruits maybe, and I want to fill this bowl with all these fruits, but unfortunately not all of them are fitting in. So there's something extra. So the solution that somebody can tell is, hey, buy a larger bowl. It's as simple as that. The bowl can't fit in. So all that I want is increase this bowl size maybe to become bigger, then this will all fit. Is this something that happens in your everyday jobs? Maybe, may not be. So that's the question. So let me go back to the 2 cases I brought about. So number 1. So the first thing I'm seeing here is users are complaining that the application is responding very slow. And on the database side, we see that the CPU utilization is 10%, which means the database is not very busy from a CPU perspective. That is all we can decide. As you all said, I want more information. So the second thing we want to know is, what is the database doing? Is it doing work or not? Now, how do we figure out whether the database is having work? And whether it is using CPU or not is secondary. But how do we know what is the time spent inside the database? For example, what I'm saying is, let me stop this slide and let me go to the whiteboard. $V session will let me know what are the sessions and what they are doing right now. But what I'm trying to say here is, let's say I have my database, which I will represent as a box here. And I of course have an app or the applications server, and my users are all connecting to my application server. There could be some sessions that are made directly into the database. Now the question I have is, what is happening inside the database? Now, why is that a question? Because we know that as per the understanding, CPU utilization is low. That's only 10% utilized. Now, the question we want to know or we want the answer for is my database using 10% of the CPU and otherwise free, or is it busy waiting for something else? Or otherwise, to put it in Oracle terms, are there other waits that we are waiting for? Because from a $V session, you will have to keep on querying it again and again and again. And that's where an AWR report, which we will come into more details later, will let me look at an overall perspective of the database or the instance, to be more precise, as to what it is doing. So it could be that the database is using just 10% of the CPU and not doing anything else, which means there are no waits. Then probably the issue here is not inside the database, but maybe in the app, maybe in the network, or maybe in the client, or maybe in the network between these. So anywhere there could be a problem. Unfortunately, all of you are DBAs and you would have had this situation where anything as a problem from an application, the first culprit is the database, even without knowing whether the problem is there or not. It is always reported the database is having an issue because it's an easy blame game to put up. I have nothing against anybody, but that's a typical approach that is taken. So that's the first part. Any things that you want to say here about whatever I told or questions, you're open to ask or specify, please. Okay, so I've even had a situation where my participants in other trainings that I have delivered come and ask, Ram, is there a way that just because there is an Aura error does not mean it's a database problem? The database throws back an error as Aura something which comes in your exception file or in your log file. That does not mean there is a database problem per se. So which is a very valid point. Now coming to the second scenario, now my database is running 80% on the DB. Now I never mentioned anything about, okay, so the users didn't complain anything here. So that's the interesting part here, which means maybe everything is working fine as far as the end user is concerned. It's just that the system administrator has observed that there is a spike in CPU utilization. So we are aware that there is an increase in load. So the first question I'm going to ask is, okay, what was the CPU utilization yesterday? Because assuming it is today that we have increased the load, what was the CPU utilization earlier? Was it 75? Was it 60? Was it 40? Was it 30? Whatever be the case. And what I realized by seeing that the CPU utilization has gone up is just that the database is using the resources. So, and I'll come back to CPU utilization shortly. We'll come back to that. So the third part, which is go for larger hardware. Any comments on this? Because this is something you might be encountering regularly. Let's buy a bigger hardware, let's buy a bigger box, our problem is going to be solved. Is this something you encounter, or what happens when we have a situation where, let's say, continuously 90%, 95% CPU utilization or memory utilization, whatever happens? Is this something you encounter? And if not in one application, in some application. So it is not necessary you need to increase your hardware. So that's what I'm trying to say here. That's not the fix. That could be a fix in some cases. Sometimes you may not be able to optimize further. So we'll come to that. So here is another interesting question, which is again summarizing whatever you might have done in your experience so far.
So do you have experiences where the systems just perform bad? When I say system performs bad, okay, here's an interesting question. How do we know whether a system is performing well or bad? So before I go into, have you had this experience? So what's your thought on that? So as I told you, I'm going to make us all think out of the box. As I told you earlier, I'm telling the same here. So a system, what is a system? Anything that is providing a service, I will call it as a system. So we'll walk out of technology. We'll walk out of technology and look at something in real life. So you go to McDonald's and you order a burger, or you go to a bank and you want to encash a check. So this is a well-oiled system, if I call it so, where you go to the bank or you go to McDonald's or wherever you go. When do you, as a user, tell that that is not working well from a performance perspective? We are here typically, we're not talking about the taste of the burger or the looks of the teller at the bank, but in terms of pure performance.
Response time.
Ah,
Time.
okay. So you're going to go by response time. And how do you tell whether the response time is acceptable or not? When do you call it as bad? Yeah, so finally it boils down to
Piece of
this one thing called SLA. That's what determines what is called as a service level agreement. So if you go to McDonald's and you don't get a burger in 10 minutes, somebody can be unhappy. If you don't get a burger in 1 hour, somebody can be unhappy. Or if you don't get a burger in 1 minute, somebody can be unhappy. So all this is okay. But to ensure acceptable response time, when I say acceptable, they upfront tell you when you enter McDonald's, there is a board that says your money back if you don't get your burger in 3 minutes. So, or whatever be the case. Or you go to the bank and they say, we will uh, give you something if we can't encash your check within 10 minutes. So the foundation behind telling whether a system is performing well or not goes back to more than hardware utilization or anything, back to the fact whether our SLAs are being met. That's nothing technical per se. That's more about identifying what is the expected response time for different operations. And once you have that, now then comes the bigger problem. How do we find out whether the SLA is being met? Now that's a different challenge. If you come into the McDonald's case or the bank case, it's pretty simple. You take a token and then you see by when you are finished with your task, we can identify. But if it is inside a database, or if it is the case of an application response time, we need to be able to track whether we are meeting the agreed SLAs. And if we are not meeting, then our system is performing bad. If we are meeting, irrespective of whatever be the load, memory, top command, ratio analysis, we are good. Does that make sense to everybody? You might still do some proactive tuning. That is a secondary aspect. You might still say, hey, we are hitting a threshold beyond which we might land up having a problem. But even though you're running, let's say 85, 90%, 100% CPU, and you're meeting an SLA, actually we don't have a problem. So that's an ideal way to look at things. Okay, now let me go back to the slide. I'm going to share my screen again, and I'm going to ask you this question, very simple question. Have you seen systems performing really bad, and have you seen systems performing really well? So when I say bad and good or well, I am looking at getting complaints from the user. So that's precisely what I'm saying. The secondary problem is where you have hardware issues. Now that's secondary, and typically hardware issues will be pointed out only when response time is not acceptable. Now it could be a OLTP response time, it could be a batch response time, it could be a data warehouse query response time, it doesn't matter. Now here is another important question on the same context. Now whatever we call as good or bad, now the question that is simple here is, was it by chance? Was it a surprise? Or was it planned? Whether it is good or bad. What's your thought? How often have you had a case where something went bad by chance or by surprise, or it was planned to run well. The fact that index was missing resulted in the performance being bad. Fair enough, you were able to identify that and you put in the index. Now the question I have is, the fact that the index was missing, was it by chance? Was it a surprise? Or was it a planned activity in the sense I did not plan for it? So what I'm trying to say here is, nothing happens by chance or surprise. If at all we say it is a surprise, it just means that I didn't think about it. That is a better answer rather than saying I didn't expect it. Rather, I would say I didn't think about it or I didn't plan for it. So when we say I have a system performing well, that's because they tested it. That is the last cycle in the delivery. But there is so much more that had to happen even before you can go about testing, and that's where the entire release cycle comes into play. So any typical software project is going to go through this. So we're going to understand what is required. Then there is analysis and design, through which they document how this is going to be developed, built, test it after developing based on whatever you designed, deploy it, and continuous maintenance and support. So the success of your product, or the good or bad performance of the product, is not just a result of here. We can't say only here. We can't say only here. We can't say only here. It starts from here and goes all the way here. Any miss we do in any one of these is a reason for performance issues. Now, let me give you a very simple example. So I want to build a system which has the following characteristics. So I'm going to say I need to create a system which is going to manage orders. It's as simple as that. So now, typically what happens next is, okay, tell me what's the functionality. And what happens there is, this is where the requirements are brought in. I want to be able to click on something, and then I need to enter whatever I want and then submit. So let me design for this, let me develop, let me deploy. And a good question which was missed could be as simple as, how many orders do I need to process per second? Now that's baffling. It might look like rudimentary, right? It is pretty rudimentary. But if we did not think about this when we created our system, then the entire cycle all the way here has gone wasted. Because if I tell you I'm going to create about 10 orders per minute, the way you will architect your system, how you design and build it, will be completely different than telling I'm going to create 100,000 orders every minute. Both are possible, right? I could have a system which does this as well as the other end. Now, what I'm trying to say here is very simple. When we take requirements, we miss about one thing called as non-functional requirements. May I know whether wherever you're working, whether you are in an end user organization or you are in the act of building applications, do you even have something called as a functionality requirement as well as non-functional requirements, typically called NFR, in your environments? So that's a very simple question. You can give me a yes or no or I don't know. All are valid answers. And if you have a non-functional requirement in your cycle, what does it capture? Or you don't have it, then I'll tell you what it is supposed to be. So what is a non-functional requirement? Non-functional requirement is pretty simple. So as I told you earlier, if I were to say I need to build a system with a particular functionality. That's just giving me functionality. But if I'm going to say there are going to be X number of inserts, there are going to be Y number of updates, and there are going to be Z number of deletes, and of course there are going to be N number of selects. Now I have, number one, taken care of all that SQL that can be happening, and secondly, what is the history transactions I need to maintain? Is it the last 6 months, 6 years, 10 years? Again, regulatory compliance needs certain amount to be kept. Then comes, to build this functionality, how many tables do I have? And how many concurrent users are going to access? Now, these all look like I don't know. Now, if you don't know what you're building, how do you know who can use it? It's as simple as telling, if you said that I want a transportation facility for going from London to New York, there are n number of ways in which the transportation can be arranged. But unless you know how many people are going to be there, are there going to be goods, what is the speed at which it has to happen, etc., etc., etc. There are a lot of questions that have to be asked. Then you will identify the most appropriate one. So there is a lot to be thought about even before building a system. And so the underlying factor we need to keep in mind is it starts from requirements. Typically people say analysis and design is important, but more importantly, capturing non-functional requirements is the first step. And if you don't capture it properly, performance is going to be a surprise. I don't even know till it goes to production, because I tested for something, what it is going to be put to use is entirely different. Now I have a different question before I go into this, and that is as follows. Let's say I have a database and you are a DBA. You're such a nice DBA, you do things proactively, meaning you don't wait for people to complain. You're having your own scripts, or you're doing whatever Oracle offers in the form of enterprise manager and stuff like that, or you're using your own tools. Whatever be the case, no complaint has come up, but you went and picked up a SQL from inside the database, which you picked up from $V session or wherever you picked up, and you saw that it ran for 30 minutes. And you know there is an SLA that anything more than 10 minutes is a problem. And you saw the SQL. And this SQL was not only taking time, it also consumed a lot of CPU. Now, what would you do as a DBA who is monitoring this database? You just went and found from $V SQL or wherever. What would be your next step? I will put the answer. It has got a Cartesian join on two tables, each having 10 million rows. And the reason this is happening is the join condition is missing. Okay. So now what will you do next?
We need to highlight the developer that
To whom?
the join condition is to the developer
Okay.
who develop the code.
Okay, fair enough. So that's precisely what I wanted as the answer. I maybe put it too easy at the upfront to give a different varieties of answer. The question that I'm going to come up next is, okay, we know there is a problem with the SQL. Okay, it could be anything else. But let us say there are 5 applications that are running, and all these 5 apps are connecting to the same database, and there are like different teams who have got each application built and deployed. Now the question is, whom are you going to approach? Rather, how can you identify from which application this query came? How would you know that? So I'm going to make things a little more complicated. You might say I will identify based on the session, username, whatever be the case. Or I'm going to make it simple, saying that there are multiple applications. All of them are hosted on the same box, meaning the application server is the same. It has got multiple applications. And let us assume all of them are connecting to the same user, which is also possible, though I'm not saying that is the right way to do it. It is possible. Now, how would you identify from which application this query came? Because each one application is going to have its own million lines of code. Each application is large enough now. And if you say that I got this query and you send it to all the 5 folks, typical response is this is not my query. How can you pinpoint exactly from where this query came? That's all is my question. Interesting question, right? Is it something you encounter, or is it something that is possible?
Yeah, we narrow down the machine or program from VDOLA session, caution the.
Fair enough. So that is where I tried to give you the googly. Ah, fine. Rahul, that's a nice thing you brought about. DBMS application info. So there is something called as module and action. I'm going to come to that shortly. But to whoever just spoke about machine and program, so I'm going to nullify that. All the applications are running on the same machine. And let's say all of them are JDBC applications. So that's not enough. That's not enough. So here is a nice thing that Rahul has brought about. There's something called as DBMS application info. Yes, in $, session, there are certain columns which generally are not populated. Things like service, module, and action. Now, why is this important? Because this course is 2 parts, and it's very simple: troubleshooting and tuning. Now, what do I mean by troubleshooting? Is very simple: to identify where is the problem, and once I know the problem, I can approach it by fixing it. Now, if I don't know where it comes from or what is the problem, it's going to be very difficult to tune it. Does it make sense? Now, this is just one scenario. That's why I said I can go on and on for 2 months talking about this each and every scenario. But the first thing is to identify where is the problem or what is the origin. So in the example that I gave, if you had used services, module action from the application side, it would have been made it easy for you. You don't need to do anything. You will just look at the $, session and you can just pick up and tell. Or if you looked at any of the diagnostics that an Oracle database can give, you'll be easily able to spot what is the source of this problem or where did it come from. Then we can exactly pick the code, because there is a possibility the same query is sitting or similar queries are sitting in 5 different places and you have no clue when did it land up having a problem. So that's something which is very, very important. So here is a very simple case to understand about this. Unless you know what is your problem, you can't fix it. So that's where I don't know whether I put it on the video or not. So let's say I suddenly complain of chest pain and I'm taken by my folks at home to the doctor, physician, and the physician checks me and then says, hey Ram, you're running a heart problem, and gets me admitted and treats me for my heart pain, or the pain that he has thought is because of my heart, but actually it's an indigestion problem. So whatever treatment he can give to fix my heart is not going to solve my problem of pain, because the pain is not because heart induced, it's because of whatever digestive problem. The other way is also possible. I go to the doc and the doc says you're having a gastro problem and he's treating me for that, when actually I'm having a problem with my heart. So I might not last even before he starts treatment, because his diagnosis, the ability to troubleshoot and find out what is the problem, has gone haywire. So it's extremely important to be able to identify where is the problem coming from and then identify what is the problem before you can do any tuning. So that's a fundamental part that I would like to stress upon here. And let's go into some basics. Now, Yeah.
One question, Rob.
Please go ahead.
We are talking about the DBMS application, right? So in which case the system or database have or the application has to be configured using those packages, right? Otherwise,
Yes.
by
Yes.
default, it is. I've not seen in many
Correct. Correct. So I will be talking
classes,
about
right?
services and DBMS application info as we go into the course. They are very, very important. I'm just bringing about points that you need to think about because yes, it's a big task to bring about DBMS application info module action into your application. It's like that's they call that as instrumenting code to be able to diagnose easily. It's a big impact, but unless you have been through a troubleshooting scenario, you don't know where it came from, you will never appreciate the importance of it. So when you're just a developer who's just building some code for functionality, one never realizes it is important to look at 2 years down the line. Somebody would have to probably look at my code and figure out where it came from, not by looking at the code in the application, but by looking at the code in the database, and they should be able to figure out where it came from. So it is lost in the cycle of development where that instrumentation ability to trace back at the easiest possible way is missed. Now, if you, I mean, I'll put the question differently. It's a very valid point. I'm going to discuss about DBMS application info and services in detail later. Now, if you look at the cycle of troubleshooting, if you've gone through one or more rounds of troubleshooting yourself, so there is the first one that problem is reported, then you start the process of analysis, then you identify what is called as root cause, and then you identify alternate solutions to fix it, and finally you nail the best fix, and of course you fix. Now in this, where do you spend most of the time from your experience, wherever you've done? So problem is reported is pretty simple. So that's the start. So you're not going to spend time on that. You're going to start between 2, 3, 4, 5, 6. Where do you spend the most amount of time from whatever you've done so far? At the time. So everybody agrees to that? So that's the underlying cause. You start the process of analysis and you have no clue about where did it come from. Once you know where it came from, then you need to identify the fix. Ideally, it would be good if I could spend my time in identifying the fix. So if I were to spend 90% of my time or 70% of my time in identifying the problem and spend 30% of my time in fixing it, but if I had an option where I don't spend this at all, the idea behind fixing this becomes much easier. Imagine that you don't have the need to do any identify root cause because you were able to just pick it out and do it. So one of the things that happens is identifying the root cause is like picking a needle in a haystack. There's a 10 meter by 10 meter haystack. Somebody drops a needle and you'll have to figure out where it is. Yes, popular answer is get a magnet and I'll pull it out. But let's say it's not a needle, but it's a toothpick. That becomes difficult. So that's what I'm trying to say here. So it is very important we have instrumentation and other means of identifying the source, then fixing it becomes easy. Agreed, Rahul. I'm not saying no, perfect. It can be case to case, but at least I don't want to do unwanted work when I have a problem. So I should be able to go ahead without figuring things out. So it varies case to case, perfect, but at least I want to spend my time least in identifying what is the problem. That's what I'm trying to say, or where is the problem from. What we're going to discuss here is about alternate storage techniques. Idea is not to get mastery in this, but to understand there are alternates available which we can consider when we work in storing tables. So as part of your data model exercise, you would have your table entities rather than tables. You will have your entities is defined, and as part of your physical model, you need to convert them into tables and decide how you're going to store them. So when we come to tables, tables can be organized in different ways in terms of how Oracle database stores them as such. So the first option is a heap table, which is a normal table. Then we have partitioning. Then we have index organized tables. Then we have clustered tables. And then we have also other alternates like materialized views, which can be used. So how is this going to impact us? Number one, a heap table is the default. If you don't specify anything, it creates a table where a segment is created and rows are inserted. There is no specific ordering that happens to the rows. Rows are randomly distributed across all the blocks. When my table grows very large, I might want to consider partitioning it. So what do we mean by partitioning? A single table will have multiple partitions. In Oracle database parlance, they become different segments. In a heap table, there is only one segment per table, whereas when a table is partitioned, it lands up having multiple segments. So what is the logic behind partitioning? So why partition and how to partition? So as I told you earlier, why partitioning comes in because we have a very large table. That's the reason you go about partitioning. So typically partitioning is helpful in a data warehouse kind of a situation because that's where you have very large tables. Very large tables run into gigabytes and terabytes. I'm not talking about megabytes. But still, even in small tables, which is running into megabytes or a few gigabytes, partitioning can be considered. So how does this help and under what conditions or how do you go about partitioning it? So partitioning basically, what is the idea behind it? It helps in saving IO. For example, if I'm having a table which is having sales data, and if I know I'm going to query it often, and whenever I query, I'm going to give a date column in the where clause or in my predicate, and whenever I'm going to query it, I'm going to query it by saying give me data for a specific month or a specific year, etc. This is what you need to keep in mind when you decide on how to partition it. If I know the date column is always present in the where clause, and because I'm going to put a restriction in terms of which date I am interested about to fetch, the partitioning mechanism of instead of keeping a single table which has all the data, I can keep, for example, month level partitions, so that when I ask for a specific month related data, my query will go and read only that partition rather than reading through the entire table. And indexes that you create also can be benefited because when I have a single large table, I have an index which points to all the rows in it. But if I have partition tables, I can have local indexes which are having entries only pertaining to their respective partition. You can also partition indexes, that is a separate activity. Instead of creating a single large index, you can create an index that is partitioned. That is a basic idea behind partitioning is to reduce IO. You think about partitioning only when you consider very large tables, and I know already which is the column that is going to appear in the where clause most of the time, so that I can redirect my IO only to those partitions which are required. This activity is called as partition pruning, where it prunes and only cuts out all the unwanted partitions and reads only the partitions that are of interest to my query. Next, I will come into IoT later. I'm going to talk about clustered table. A clustered table is a special kind of a table. Why? It is actually a segment which has more than one table stored in it. So it is like the opposite of partitioning. When we partition, we said a single table contains multiple partitions. Whereas when I do clustered, a single segment actually has multiple tables part of it. This is especially useful when you have something like lookup data, which is not modified, because if you are creating a clustered table, making DMLs on it is not going to be of help. There is a way in which it does. We are not going to go into the details of clustering. There is hash clustering and index clustering, things that are there. We'll not get into it, but I'll give you an understanding of how it comes in of help. So when I have lookup data, for example, I have country, state, city, three tables which are logically identified as three separate entities. But I know whenever I query these tables, I always access them by joining them. When you create a clustered table, what happens is you first create a cluster, which is a segment, and then you create tables in such a way you tell you will keep them together. So in this case of country, state, city, country is a parent, state is a child, state is a parent, city is a child, and the way this data will be kept is in such a way country, state, and city will all get co-located for a particular country, for a particular state, such that when you join and fetch the data, instead of going and joining three different tables and then doing a join, it will actually get the data together. When it goes there, it already has the data organized together. It will keep it such that the parent-child data is kept co-located, so that instead of doing a lot of IO across multiple segments, I can come to a row directly and fetch all rows across all tables that are clustered.
Yes, question.
Yeah.
Then why I wouldn't keep a denormalized table?
You can keep it as a denormalized table, perfectly valid point. But when you are doing entity relationship modeling, you anyway identified three separate entities called country, state, and city. And you want to keep them as it is. Internally, what is happening is a denormalized setup. And when you do a
Okay.
normalized setup, what happens is every value is repeated. So the country, state, city, the country value will get repeated. So you don't gain compression by doing that. But when you keep it like this, country value will be kept once along with all its states and cities. So it is an optimized way to store it in a more optimal manner.
Okay.
And as I told you, this is typically useful where you don't do inserts or updates or deletes on these tables. So that's where seed data or lookup data are optimal cases to do that.
A quick question on this now. So
Yeah.
the tables which form the cluster tables, right?
Mhm.
Have they are they usable as individual tables, or can
You can access country separately, state separately, and city separately. You can access them tables. You still have the three tables as such visible as tables which you can query individually. So the problem would be if you were to fetch only country data, you will still have to do a lot more IO than if the country was a separate table and a segment by itself, because it has got more than country data as such physically. So when you query these tables individually, you will actually end up doing more IO than if you had not clustered it. So that is an overhead that you will have. So everything
yeah, exactly.
has its own benefits and problems. We need to know both before we implement something. But know under what circumstances which is going to be of help. Then comes materialized views. Now I have two more topics pending: materialized views and index organized table. Now materialized view is basically a summary table. For example, I have two tables. I will call them as T1 and T2, and I run queries which need to fetch from both. There is a join on this. So what is going to happen when I run this query? Data will be fetched from T1, data will be fetched from T2, then in the PGA it has to do a join based on the condition and then give the output. This means there is a runtime computation overhead. Every time you run, it has to do it. Now, what if you decided, I want to pre-compute this result and keep it as a table? You can do that by creating a new table T3, who will be created as select star from T1 and T1 and T2, where condition, etc. And you can put it here. Now, the challenge with this is you have to change your application code. Wherever you were running the original query, you need to replace it by saying fetch it from T3. So there is a code change involved. And you would have to manually take care of synchronizing T3 to refresh it whenever changes occur in T1 and T2. So there are some challenges. This used to be happening before. And under what circumstances is this going to be help? When I do either these kind of joins, and it is not necessary I need to have T1 and T2. It could just be T1 where I'm doing an aggregate. Let's say take the same case of sales table that I told you earlier. I will go and query the sales table and ask it for give me sales by month, wherein I want all sales across every month to be aggregated and given, which will again result in a runtime computation that has to happen. Instead, I can run the query once and keep it so that when people are going to query that again and again, they get the results faster. So that's the idea behind creating a materialized view. The difference between you manually creating a summary table and using a materialized view, there are quite a few. Number one, you will have to create the materialized view, and when creating the materialized view, you have options to specify the refresh case. Do you want the materialized view to be refreshed automatically whenever the base tables are changed, or you will want to manually refresh? You can have a situation to say that, hey, look at this, all these queries will get data as of yesterday. You will not get today's data, wherein today's data is getting entered into T1 and T2, and in the night I will update the materialized view, and tomorrow I will get data as of day before it, as of today. So every day I will have data as of yesterday. So that is one option. Or you can do on commit refresh, wherein the materialized views automatically refresh. So depending on the rate at which you make changes to T1 and T2, you can decide on the refresh options. The beauty about materialized view is no code change. What do I mean by that? I have my tables T1 and T2, right? And based on a particular SQL, I created a materialized view. The difference between a materialized view and a view is very simple. A view is just the SQL, whereas the materialized view contains the data also. The result of the SQL is kept there. Now, from the application, you are running a query. The query is still going and asking for data from T1 and T2. But the optimizer can realize, hey, this query that I'm fetching is already pre-computed and kept in my materialized view here. So it will rewrite the query as fetching from MV and internally generate an execution plan which will fetch it from the materialized view rather than going to the tables. Which means you as a DBA can create materialized views which will result in your queries from the application running much faster than before, though no change has happened to the application as such in terms of rewriting that to fetch from the summary table, which was the case earlier. Then comes the concept of an index organized table. Now, let's understand the concept of a table. Let's say you create a table and I have my table with various columns. Let's take a simple example of employees table, or okay, I will take the package table. This is a case of a courier company like FedEx or somebody. Now take the case of the package table. Now what is this package table containing? It contains an ID for every package. It contains the current location, source, destination, and whatever it has got. Okay. Now, what is somebody going to do with this? Typically, they are going to either update the current location, or somebody might want to check the status of where is my package right now, which is just to query it. Now, this is a typical OLTP situation wherein always I will have something like where ID equal to something. This will always be part of my query, which means I want to always go and hit a particular row and look up for the value or update the value. This is my scenario. And that's why my example that I've given is something like a stock market scenario where people look up for a stock price. So give the code and give me the current price of that stock. That's what is the objective of what you do in a stock market, and then you make a trade. Now, the best way I could have optimized this was to create an index on the ID column. And by doing that, what will happen is whenever I put this, my query plan will go to look up into the index, fetch the row ID, then go to my table, fetch the row. So it has to look up into the index first, which is a separate segment, then go up and look up into the table and then get the row and give you the output. This is a standard mechanism which we follow. And generally, if the ID was a primary key column, automatically the index is created. So for all primary keys and unique constraints, an index is automatically created. And this is the standard behavior. So you don't need to do anything to optimize it. If you ensured constraints are in place, you are taking care of the right index is also automatically created. This is standard behavior. I've still not come into what is an index organized table. That's what I'm coming into next. If I were to create this table as an index organized table, as the name suggests, index organized table, if I create a table as such, actually only an index is created. And when I create an index is always ordered by the column, right? The index organized table is ordered by the primary key, which means I will have an index organized table created, which will be ordered by the primary key, in this case ID of each package that you're sending. And actually there is no table segment. The table, even if you keep inserting more and more rows, will be always ordered by the package ID. Now, whether you want to update a row or query a row, you actually are reading only an index. So you will not need to go and read a separate index and then come to the table. There is no separate IO to read from an index. The table itself is organized as an index, which makes it faster to look up because you will do lesser IO. But there is a challenge here. The challenge is if my table has got 10 columns and 2 of them are primary key, and I frequently query only the first 4 columns, like the package status is what I keep checking again and again. If I organize the index with all the 10 columns, the index will have all the 10 column values because the IoT contains all the values. So what you can do then is you can split this into 2. Now, what do I mean by that? You keep only the first 4 columns in the index organized table segment, and you have something called as an overflow segment, which can have the remaining 6 columns. So this is a choice you can make. In the example I've given, I've not used it. The idea behind doing this is I want to keep as many rows as possible inside this so that I look up and get the result as fast as I can. And the only columns I'll keep in the IoT are the frequently used columns. And the other less frequently used columns, I move it into a separate segment wherein whenever I ask for them, let's say 10% of the time I ask for the other 6 columns, then it will come to the IoT, fetch the row, and then for the other columns, go to the IoT and do the additional IO. This ensures quicker access to my row. That is the objective. Basic idea is by reading a certain number of blocks, can I get maximum number of rows with the columns of interest. You could have done this differently also. You could have said, okay, I'm going to split my table into two tables. Instead of keeping 10 columns together, I'll keep 5 columns or 4 columns in one table and 6 in another table with a 1:1 relationship. But still, each table would have had its own index. So there would have been still an IO on the index and then come to the table when you look up based on the primary key values. That is avoided here. So then comes the topic of index. So sharding. We have not included sharding in this topic. This is a new feature that was released in 12C release 2. So basic idea behind sharding, I'll tell you. It's some kind of partitioning. Okay. It is a means of partitioning. And when we talk about sharding, this is something that has been inherited from NoSQL database concepts. Generally, when we talk about partitioning, we are talking about a single database in which a table is split into parts and kept. Now, when we talk about sharding, this is a concept where I have multiple databases. Okay, this could be located across geographies, and I have a table which is located everywhere, but I keep some data here, some data here, and some data here. Why do I keep it that way? Because I know based on the geographical location, something like user profiles, people in India log into their Facebook in India, people in US log into their Facebook in US. So I'll create a user table, but I will tell keep all users whose location is US to be kept here, all in UK to be kept here, all in India to be kept here, so that the application locally access it. But at a concept level, all this together is the same table. Is the concept clear of sharding?
Yeah, Ram. So these are different databases, right? Not rack instances.
No, these are individually different tables.
Table structures or
Sorry.
databases.
They are individually different databases. The tables are also created in each, but you shard the data across the databases. You basically partition and keep the data co-located with the application use case so that you manage it accordingly. Now, when it comes to index, we use indexes to be able to access the data as fast as we can. There are different types of indexes. I'm not going to bother too much about it, but I want to tell you something which whether you thought about, I don't know. And my question here is, what is an index and how does it work? So what is an index according to you?
Yeah, in index, you generally keep the row ID of a block from which it quickly access the particular block which it actually needs during the execution time.
Okay, you brought about two terms, row ID and block. I would correct you here. Row ID is not for a block, but as the name suggests, it is for every row. If I were to have the table of orders and I have ID, customer name, product that was bought, whatever be the case, if I want to go and query for a particular order, and if I did not have an index on the ID column, my query would have read through the entire table. Instead, if I create an index on the ID column, and if my where clause said where order ID equal to something, it can come to the index, look up for that order ID, pick up the row ID. What is this row ID? The row ID is basically an address of a row. So which file number, which block number, and you can directly go to that. It's like saying, if I want to visit, let's say Natraj, and Natraj lives somewhere in the US, and I don't have his address, but I want to meet him. Look at what I have to do to find him. I know his face. I have his face, and let's say I don't have to worry about the entire US. So he's in Colorado. That's all I know as of now. So if I have to catch hold of Natraj for whatever reason, I have to come all the way to Colorado, then go and spot every house and see if Natraj is there. That's what a full table scan does. Go into every row and see whether what that row contains is of interest to me. On the other hand, if I had an index of addresses of the people I want to visit, and I want to visit a particular person, I look up for his address and I directly go to his door because I will have his door number, his street name, his area name, etc. I'll be able to visit him without having to go through each and every door. That's what an index does. So an index enables fast access to a table, to a row in a table. But there is a problem in having indexes. What is that? Every time you update a column, its corresponding index is also updated, which means an update on a table results in an update on the table as well as the index, which is an additional IO in the buffer cache, which will result in additional IO to the disk. So indexes generally help in performance of queries, but they impact performance of updates. Unless you are looking to update a particular row, you are looking at a particular ID, you go and fetch that ID by using the ID index, but you are updating the product name and you have an index on the product name, for example, it will have to update that. So that's what is the idea behind indexes. And there are different types of indexes. Again, going through that would be too much. Consider what is the best option for you. And that's what is the discussion point here. So partitioning is something I talked about. IoT is something I talked about. Materialized views is something I talked about, which comes to the end of this practice. You have a practice to identify why packing rows tightly is going to help, how an IoT can help. I think I have not used reverse key indexes because of a particular reason. I don't want to confuse you further. You can explore it later. And there are also a couple of videos which you can consider looking at a later point in time.
I have a question.
Yes, please.
Related to index. When we consider creating a local index or a global index, it will be helpful in my scenario.
Okay. So your question is, under what circumstances for a partition table should I create a global index? And under what circumstances a local index would be preferred? So a local index is an index which is partitioned for every table partition, right? So to give you an example here, so I have a table which has got split into partitions, and let's say I will take the same case of my sales table, which is partitioned by year, which is a column. So I have, let's say, 2010 data in this partition, 2011 data in this partition, 2012 data in this partition, and 2013, just some example. Now my queries are going to have where year equal to 2010. If this is all you're going to have in the where clause, then no problems, you can go through this. But let's say you are also bothered about and amount greater than $1,000. Now, given the fact that when I put where year equal to 2000, I have told my SQL, please go and look only into this partition. But the fact that I have another where condition which says amount greater than 1000, why would I want to go and read through all the rows? Instead, if I can create a index on the amount column, and I will create it as a local index on amount column, such that my assumption is whenever I query this table, I will have the partition key in the where clause and an additional column that is going to appear in the where clause, so that I will visit that partition and then use the index and only go to those rows. This is where a local index comes in of help. Is this concept clear so far? This is a case to use a local index. But let's say I also run other queries where I will say product equal to X. I want to know in which all years in my company people came and bought a television or whatever I'm selling. Now I am not bothered about going into a specific partition. I want to look across partitions for a particular condition which is not having the partition key in the where clause. Then what would happen is my query would have to go and read through everything. Instead, if I can create an index which is global in nature, when I say global, it is maintaining rows from all partitions such that when I put this kind of a query, my product index can be looked up, then identify the list of row IDs as to which are the customers in which order IDs had television sold or like products X sold, and pick it up. So when you don't have your partition key in the predicate and you're going to search something across partitions, a global index comes in of help.